Microsoft Research brought together leaders in the exciting field of machine learning at a major summit in Paris. We are pleased to offer Research in Focus interviews with participants at the Microsoft Research Machine Learning Summit 2013. And I am joined via Skype by Dr. Francis Bach of INRIA and Dr. Leon Bottou of Microsoft Research. They're going to give us the lowdown on large-scale machine learning. Gentlemen, welcome.
Well, thanks for having us.
So for those who aren't in the know, can one of you explain exactly what large-scale machine learning is and how it differs from other kinds of machine learning? Start with you, Francis.
Yes, so I think to start, large-scale machine learning is machine learning. So you still have problems where you want to deal with data, but the main difference is not the data is so large that you have to be a bit more careful in the way you handle it than you had to before. So this large scale comes from the need from applications.
Leon, anything you want to add to that?
Yes, it's also a change in the way one looks at machine learning, because I'd say that in the past 20 years, most of the focus was on dealing with small data sets and large computational power. And because data is now collected automatically by computers, we have quantities that are so large that they have grown faster than the power of the computers. So we have to invent smarter ways to deal with them, and different ways.
So, Francis, why can't the same algorithms that worked on small-scale data sets work with large ones?
Well, typically, algorithms from 10 years ago, they will look at the data multiple times, okay? And since the most costly part typically is to access data, then those algorithms will end up looking at the hard drive over and over, and they become simply too slow. So that the first problem is pure computational speed. You can't run them. But the other aspect is that when you have more and more data, then you may have to ask more and more questions. Okay, so this causes as well new statistical problems, because as soon as you have more questions, then you have it's a bit harder to answer.
So, Leon, couldn't you get around the computing power problem by having a multitude of computers running in parallel?
Oh. And the reason is the following. If you have an algorithm and its requirements in computing time grow, let's say, quadratically with the size of the data, which is something that is common in machine learning, and if the data grows faster than the total computing power that you have, then you're cooked, because you're never going to be able to handle all this data with the computers you have. Another way to look at it is that the data is generated by computers themselves. So when you have more computation power, you have more data. So if you have an algorithm that is more than linear in the volume of data, you basically cannot process it.
All right, Leon, so you need to use different algorithms. What algorithm or algorithms work best for large-scale machine learning?
The first thing to understand is that they have to be different. Now, which one works the best is not completely solved. But what we know is that there are algorithms that are considered bad at optimization in the standard setup. And they happen to perform very well in the large-scale setup because they're very light in their use of the data, because they see it just only once, or because they process each item very quickly and therefore can catch up with the stream of data that's coming. And because of this, algorithm like stochastic gradient descent, which is a bad optimization algorithm, proves very effective in the large-scale scenario. And now it's being used extremely frequently by a lot of actors in that field.
Francis, can you talk about some cases where large-scale machine learning has been successfully used?
So I think one example I know of is computer vision. So in computer vision, typically you want to predict, I give you an image, and you want to see what's in it. Okay, and of course, you could ask an expert to give you a model of all possible objects in the world, okay? But the problem is that you have too many objects, and a common practice is to acquire a lot of data, which you label somehow, by telling by giving the computer a bunch of images with some of them have vehicles, some of them have motorcycles, And once you have millions of such images, or even billions, then you try to learn what a vehicle is, a car or a bike. And those types of machine learning techniques have been applied in object recognition. And now you're able to recognize a lot of objects from a lot of images.
Now, I'd love to get you both to weigh in on this one, and Francis, we'll keep it going with you. What are the biggest obstacles that face large-scale machine learning?
So, of course, to me, I see the computational obstacle that Léon has mentioned. But to me, the important one as well is a statistical obstacle. The main issue is that big data is still data, okay? And you cannot get away with it. So you still have to pose questions to the data. And this is often a problem which is hard to explain to new users of machine learning. They tend to think that data would do it all. Data could do a lot, but you still have a need to have a statistical way of seeing that data, ask questions, try to answer them correctly. So to me, a big obstacle is on the interaction between us, machine learning scientists, and people that own the data.
Leon, what do you think? Biggest obstacles?
I can give an example maybe of what Francis just said. If you consider search in web search, typically there is a ranking function that is trained by machine learning that's going to say which results are the most interesting to show out of all the possible results for a particular query. But now if you look at the queries, some queries are extremely common, frequent, and you have a lot of examples for this. And that's pretty much easy to learn. And you have queries that are very rare, queries that are entered once a month. And if you want to give a good result for this, now you have a problem because for this particular query, you have very few examples. So in the same problem, you have the whole scale of statistical problems, from statistical problems where the data is completely abundant to statistical problems where the data is very scarce, except that you no longer have one such problem. You have billions of them at the same time. It's not sufficient to say, oh, we have big data, it's going to be easy, we just need to harness the computational problems. You have to be smart too, because you have to deal with problems that are statistically difficult and large quantity of them at the same time.
So what do you think is the next big thing in large-scale machine learning? Are there some paradigm-shifting changes in the offing, both in terms of the way large-scale machine learning is done, or major results maybe on the horizon?
There was one shift, and that shift was understanding that large-scale machine learning is different in terms of algorithmics. And there is a new shift, and Francis hinted at that at the beginning, which is when you have a lot of data, if you just work on one particular problem and use more and more data, you have diminishing returns. So the richness of all that data is in the diversity of problems you can solve. So you need to ask new questions. You need to use data to solve new problems and ask new questions. And a clear understanding of this is not available at the moment, and I'm expecting to happen at some point.
Francis, what's the next big thing?
One of the big problems with those large amounts of data is that you have a needle in a haystack problem. So what you are looking for is typically hidden in the data. So you have this. You need to search for very specific concepts, and this to me remains totally unsolved. So you have more observations, but you want to ask questions which are so much more difficult than we're still very far behind what we could do with that data. We have millions of, we have gigabytes of observations, but we're only able to answer very specific queries because we don't know where to look. So this is clearly a big open problem with lots of potential impact if it is solved.
Well, clearly this is a field with a large-scale future. Thank you both so much for sharing your thoughts with us today.
Okay, thank you.